Today we will be discussing about the relationship between molarity and normality. Molarity is expressed as m. It is given by the equation N2 by V, where N2 is number of moles of solute, V is volume of solution. Then this N2 is nothing but W2 by M2. So we can replace this equation as W2 by M2 into 1 by V. And N2 is nothing but the number of moles of solute. So solute is the smaller portion of the solution. So it is represented by the subscript 2, whereas solvent is represented by 1. When I put N1, then it is called number of moles of solvent. So here V represents the volume of solution, but its unit is liter. Now let us see this molarity, how it can be represented in various ways. So you should have some convention like that is always take 1 as a solvent, 2 as solute. So these two are present in solution. There is an equilibrium between that is a solvent and solute to give the solution part, is it not? Then N2, when I ask you what is number of moles of solute, you should be able to tell that is the weight in gram divided by molar mass of that particular solute. Now, you know something about density. So density is equal to weight by volume. What is density? Weight by volume, or you can say mass by volume also. So its unit is gram per ml. So if it is given in gram, then it should be interpreted in terms of volume as ml. Okay, so gram per ml. Sometimes it is represented as a kg per liter also. It depends, but let us go by gram per ml. And based on that, we can find out volume, is it not? So the volume can be expressed as W by D, is it not? Where W is the weight of the solution and D the density of the solution. So, and W is, as I already mentioned, it is the weight of the solution in gram. So, general convention is we represent the density in terms of gram per ml. Okay. And remember always this V is given as liter only. Okay. So if you want to give this in ml, then you should divide by 1000 because 1000 ml is equal to 1 liter. Okay. So in that case, you can divide by 1000 so that the equation becomes a W2 by M2 into 1 by V by 1000. Is it not? So this 1000 can be reciprocated. V by 1000 can be reciprocated. So that W2 by M2 into 1000 divided by V. So in this case, V represents volume in ml. Do you understand? Right. Okay. So this volume of the solution can also be represented by replacing this W by D, is it not? So V is equal to W by D. So you can suitably replace this volume of the solution by W by D. Okay. Now the equation becomes W by W2 by M2 into 1000 into D divided by W. You know D density in gram per ml, W weight in gram, that is weight of the solution. Okay. Then you know already M2 M2 molar mass of the solute, W2 weight of the solute. Okay. So you can straight away make it as volume as liter. So in that case, W2 is equal to M into M2 into V. So when it is given in ml, divide by 1000, otherwise leave it as such. So M into M2 into V. So this is equal to W2. So weight of the solute. So by knowing this value of molarity, molar mass and volume of the solution, you can straight away calculate the weight of the solute present, because whenever you have got some equation, there are every chance of asking questions in different ways based on the parameters they can ask. For example, if you have got four parameters, three parameters will be given and fourth parameter can be asked. Anything it can be. So weight by volume percentage is nothing but W2 by what? V into 100, where V is given in ml. Is it not? For example, when I say 5% NaCl solution means that is 5 gram is present in 100 ml solution. Is it not? Not 100 ml in water. So you had to always consider the made up solution, made up volume of the solution. Okay. Let us consider again density. You know, density is nothing but weight by volume. W by V is equal to W2 by V into 100. That is W. Now, when it is given as weight by volume percentage, you know very well W2 by V into 100. So D is equal to W by V. That is another equation. Okay. So V is equal to W by D. Therefore, M is equal to molarity that we already know, W2 by M2 into 1 by V, where V is the volume of the solution in liter. So M is equal to W2 by M2 into 1 by, here we can put V dash divided by 1000. So if it is given in ml, you have to divide this by 1000, is it not? So it becomes W2 by M2 into 1000 divided by, you can put V dash. So when I mention V dash, which is nothing but volume of the solution in ml, and V represents volume of the solution in liter. So D is equal to density, that is always given in gram per ml. So V dash, so instead of putting V, we can maintain V dash for ml. Okay, so V dash is equal to W by D. So we can substitute suitably the V dash by W by D. So M is equal to W2 by M2 into 1000 divided by, instead of V dash, you can put W by D. Okay. Therefore, M is equal to W2 by M2 into 1000 into D divided by W. Is it clear? Where W is equal to weight of the solution and D density of the solution. Okay, so by knowing the density of the solution, by knowing the weight of the solution, then the molarity of the molar mass of the, molarity of the molar mass of the solution, not solution, solute, then weight of the solute, we can determine the molarity. So based on the density also it can be interpreted. Okay. Now let us talk about normality. It is represented by N. So N is equal to EQ2 divided by P, where EQ2 represents the equivalent mass of the, that is equivalent of the solute. Like mole of the solute, we represent by N2 moles. Similarly, equivalent. Okay. What is equivalent? Equivalent is nothing but weight by gram equivalent weight. So we can replace this equation by W2 by gram equivalent weight of the solute into 1 by V. Remember this V is in liter. So W2 by M2, and that is a gram equivalent weight is nothing but M2 by E, that is molar mass divided by valency factor. So W2 by M2 divided by E into 1 by V. So now this E is reciprocated. So you are able to get W2 by M2 into E by V, is it not? Now we already know W2 by M2 into 1 by V as M, molarity. So we can suitably replace, therefore N is equal to ME, is it not? So where E is the valency factor. Okay, E is the valency factor. So now we are able to establish the relationship between normality and molarity. Therefore, what is molarity in terms of normality? Molarity is equal to normality divided by E. That's all. Okay. Now, we should know something about the dilution. When we dilute, what happens? When we dilute a solution of particular concentration, so in terms of molarity M1, then on dilution, on adding water or solvent, suitable solvent, it becomes what? Less, concentrated. That is, the concentration will differ. Yeah. So it becomes M2. So M1 becomes M2. So M1 V1 is equal to M2 V2. Okay. So this is the formula you should know. Where M1 is the molarity of solution 1 before dilution, you can say. Then it has become M2 means molarity changes. So molarity of the solution after dilution. It means molarity of the diluted solution. And the V1, V2, the respective volumes, is it not? So V1 is the volume of what? The solution before dilution. V2, the volume of the solution after dilution. Is it not? You would have added some water or some solvent. So there is an increase in volume. So the volume is also getting changed here. So it becomes a V2. So V1 is the volume of the solution before dilution. V2 is the volume of the solution after dilution. Okay. So based on the dilution concept also, you can anticipate some problems, some numerical problems. Okay. It will be quite interesting if you have that is a such formula already that is memorized, then it will be very comfortable for you to crack the problems. And this can also be instead of molarity, you can be asked in normality also. In that case, we have the relationship between normality and molarity. So n is equal to me we can put. After all, in case of dilution, we'll be handling the same liquid, is it not? So there is no question arising of valency factor. So both of them will be cancelled. But in the case of, this equation, that one is for dilution and this equation is for the volumetric analysis. Okay. So it is the equation represented or very important, which has a very significant role in calculation of the strength of the given solution or experimental solution. So M1 E1 V1 is equal to M2 E2 V2. This is the equation of titration, volumetric titration. Okay, probably that is you would have been given in your practical, that is laboratory, that is potassium permanganate versus oxalic acid. So this is the redox titration. Then in the case of acid-base titration, you have sodium oxide, sodium hydroxide versus hydrochloric acid or sulfuric acid, something like that. And you should know something about the equivalent mass also, because whenever you calculate normality, equivalent mass is also very, very important. So without that, it would be very difficult to determine normality. So let us find out what is normality and what is equivalent mass. We have just now discussed about normality as W2 by gram equivalent weight into 1 by V, where V is the volume of the solution in liter. Whereas a gram equivalent weight, you can express this as a gram equivalent weight, that is GEW. So being a solute, you can put a GEW2 also. So GEW is nothing but molar mass divided by valency factor. So we should know something about this valency factor. So what is this valency factor? First of all, let us try to understand what is a valency, what valency is. The binding tendency, it is the number of electrons available in the outermost shell. Okay, that decides, okay, for an element to interact, how it can be interacted with how many entities it can be interacted or develop bond. So this is the valency arrangement. So the valency factor for hydrochloric acid is 1 because it delivers H plus, 1 H plus. It's a monobasic acid. Nitric acid is also monobasic acid. Its basicity is 1. It means it is capable of delivering H plus 1. And similarly for phosphoric acid, it is 3. For sulfuric acid, it is 2. For sodium hydroxide, it's 1 because hydroxyl ion is 1. Similarly, calcium hydroxide, 2 because it has 2 hydroxyl unit. Now the valency factor as we have already mentioned, the molar mass is very important in calculating the valency. So in that case, we have to, that is, determine which is the dominant one in a molecule. For instance, calcium chloride or barium chloride. So barium has dominant valency 2, chlorine has 1. So which should be taken? 2 should be taken. So 2 should be considered as the valency factor. So when you are asked to find out the gram equivalent mass of barium chloride, what you are supposed to do? Molar mass of barium chloride divided by 2. Okay. And for oxidizing agent and reducing agents, oxidizing agent like KMnO4, acidified KMnO4, potassium permanganate or potassium dichromate, K2Cr2O7. Okay, in that case, the number of electrons transferred during the reduction or oxidation process. As you know, oxidizing agent undergoes reduction, reducing agent undergoes oxidation. So during this reduction and oxidation, how many electrons are transferred? In the case of manganese, 5 electrons are transferred because the oxidation state of manganese in KMnO4 is +7. So that becomes a +2 in MnSO4. So +2. So 7 becomes a +2 means 5 electrons are transferred here. So it should be divided by 5. Do you understand? So the gram equivalent weight for any mass, any substance is molar mass divided by the valency factor. If it is hydrochloric acid, molar mass of HCl divided by 1. If it is sulfuric acid, molar mass of sulfuric acid divided by 2. If it is potassium permanganate molar mass divided by 5. Okay. So I have once again explained here manganese on electronation, that is 5 electrons that become Mn2 plus, and that is why we divide this by 5. So it's a 5 electron transfer. Gram equivalent weight of oxalic acid. We can write oxalic acid in this way, COOH, COOH, that is H2C2O4. So usually laboratory reagent they have 2 water molecules also. So you have to consider that one also. So H2C2O4, 2H2O. So when you calculate the molar mass, you have to include the dihydrate, 2 water molecules also. So it becomes 126 and its valency factor is 2. So the equivalent mass of oxalic acid is 63. Okay. That is 126 divided by 2. 126 is the molar mass of oxalic acid dihydrate. So when you write equivalent mass, you have to write 63 gram per equivalent. Okay. So thank you very much for watching this video.